go together like rama rama rama, ding 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 dong. Remember forever and shoo-bop, shoo-wada wada, yippity boom de boom. Chang chang, changity chang bop. That's the way it should be. Wow, yeah.
Hi, in this video we're going to talk about correlation. And correlation is just a fancy word for saying are two variables related? We can talk about them in terms of positive correlation. And what that means is if we graph these on a scatter plot, if as one increases, the other increases. In other words, notice that my trend is going here. And if I put a line on here and have a positive slope, okay, then it is called a positive correlation. In other words, they both increase together. We can also have a negative correlation. Again, if I make a scatter plot, but as one increases, the other one is decreasing. In other words, if I fit a line and it would have a negative slope, then we would say that it has a negative correlation. We measure correlation by calculating what we call the correlation coefficient, and we denote that as R. Okay. Now, when you calculate the correlation coefficient, there is a long formula for it, but I'm going to show you how to do it in Excel. What the result is you end up with a number somewhere between -1 and 1. So the value of our correlation coefficient R will be a value between -1 and 1. The closer the value is to 1 or -1, the higher the correlation. So for example, if I calculate my correlation coefficient and get R equals 0.85, it's a relatively high. And then notice that this is a positive number, so it's a relatively high positive correlation. And we can sometimes interpret this to mean that 85% of the variation in one variable can be explained by the variation in the other. So that's what the actual number means. If I calculated a correlation coefficient and got -0.12, well, it's a low, and again, this is a negative number, so negative correlation. And what we would say is these aren't really correlated at all. In other words, only 12% of the variation in one variable can be explained by the other. So that brings us to the question, what is a good correlation? Well, there's a chart for that. In our book, table A6 gives you the ideal correlation coefficients depending on n. Obviously, if we have a lower n, we'd expect our correlation number to be higher. And as we increase our n, acceptable correlation values can be lower. The way you use this chart is you find n, in other words, your number of observations, or the closest value to that. And then typically we use alpha equals 0.05, so you can ignore this column for purposes of this class. And if your value is greater than this table value, okay, then you have a good correlation, okay? So we're looking for a value that's greater than our table value. And what we would say in place of good is we would say significant, meaning it is statistically significant correlation, okay? So we look up our n. If our value is greater than the table value, then we have a significant correlation. Now, I've got an example in Excel because we're going to calculate the correlations in there. I took the 2017 football statistics off the internet. So for each team is represented here. And what I was looking at is their winning percentage, the percentage of games they won, versus the points they scored or the points they allowed or a point differential. And what I've done to begin with is to graph these over here. So what you're looking at in this first graph is the winning percentage and then the points scored by the team, the total number of points for the year. For example, here, this particular data point, this team had a winning percentage of 81.3% and they scored 382 points that year. All right, and what you can notice, even though it's not always obvious, but as the winning percentage increases, The total number of points increased. So we would guess, based on this scatter plot, that this has a positive correlation. If we look at the second graph, I've graphed the winning percentage versus the points allowed by the defense. In this graph, you can see that as our winning percentage goes up, the number of points allowed goes down. So I'm reminded of the saying, does good defense win games, right? So this may actually answer the question, is your best offense a good defense? And we'll get to that in just a second. Finally, they had the point differential. In other words, for each team, they took the total number of points scored minus the points allowed. So some are positive, some are negative, and then graph that versus the winning percentage. And you can see here that as the point differential increased, in other words, they scored way more points than they allowed, then our winning percentage went up. So if we wanted to calculate a correlation coefficient for each one of these, we'd have to do it separately. So the first one I'm going to calculate is the correlation coefficient of winning percentage versus points scored by the team. And that's going to be this WL% and the PF. Now the way I do it in Excel is I'm just going to click on a cell, and our keyword, you're not going to remember this, but it's Pearson, P-E-A-R-S-O-N. The reason is that this is sometimes called the Pearson correlation coefficient after the person that developed it. So you can see here to the right, it says correlation coefficient, comma R. So we type in equals Pearson, open parentheses, and then we highlight the first set of data, and then we put a comma. Okay, so notice my comma here, and then we can highlight the second set of data. And now when I hit enter, it will generate our Pearson correlation coefficient. So in our first graph, our Pearson correlation coefficient is 0.8388 if we round to 4 decimal places. So the correlation of winning percentage to points scored is 0.8388. It's a positive correlation, which we suspected, and it's relatively high. And we'll look at our chart in a minute to see if it is significant. Now let's look at the correlation between winning percentages and points allowed by defense. I'm just going to repeat the process. Click on a cell, equals Pearson. And now in this example, I'm still using the winning percentage, so I'm going to highlight those data, comma, don't forget your comma, and now I'm going to go over here to points allowed and highlight that data. And enter. So when we look at winning percentage versus points allowed, we get a negative 0.7934. And again, if we look at the graph, it does appear to have a negative correlation, right? As winning percentage increased, the number of points allowed decreased. Now, if we just compare the two numbers, we can compare the absolute value. In other words, ignore the negative. It appears that the correlation of winning percentages is higher versus points scored. So the old adage that a good defense wins games is probably true, but according to this data, a good offense is going to be more indicative of winning, okay? Even though they're very closely related in terms of absolute value. Finally, let's look at that differential. Let's calculate the correlation coefficient for that. All right, again, click on a cell, equals P-E-A-R-S-O-N, open parentheses. I'm going to click on the winning percentage, comma, and the point differential. And we get 0.9088. So this is going to be 0.9088. And now this is our highest number. If we compare the three, it is positive. So if I had to predict winning percentage of a team, I would probably have more correlation with winning percentage by taking that differential, points scored minus points allowed, than the other two. Now, are these numbers significant? Well, I would have to go to my chart. So let's look at the total number of teams we had. So we had 32 teams, okay? In other words, there's 32 data points here. I would go to my chart and look for n equals 32. I can see that I don't have a 32, so I'm just going to round 30. Anything above 0.361 is going to be significant. Anything above 0.361 is going to be significant. So if I go back to my data, notice that all of these are above 0.361. If you have a negative value, you have to take the absolute value. In other words, just ignore the negative. All of these are above 0.361, so they're all significant. In other words, there is a significant positive correlation here, a significant negative correlation here, and again, another significant positive correlation. So that's how we calculate it. Again, in Excel, it's fairly simple. You just type in equals Pearson, open parentheses, your first data, then your second data, and it will return your value here.
Change, change, change.